Well, this project initially started where we developed the concept of creating a photoluminescent nanofiber that by combining nanofiber materials and other luminescent materials, we could create a unique structure that could emit light, and that we could use this to generate light that could ultimately be used in a lighting device such as a light bulb or a luminaire. And with that information, we were able to successfully write a proposal to the Department of Energy, where we have been funded from their core technology lighting program for the past 3 years.
The goal of the project is to develop a light source that's more efficient and has better lighting than incandescent and fluorescent lighting. And there's no gas involved, there's no glass involved, so there's no breakage or toxic leakage of gas into the environment. So it's more environmentally friendly and more efficient, and it's really where lighting is going.
When I talk about a nanofiber, what I'm talking about is a polymer material that has a diameter very much smaller than the human hair. And an individual nanofiber, we're able to create unique structures that change how it manipulates light.
So we take a solution of polymer and we put a high voltage on that solution, and at some point the solution can no longer hold that much energy, and small streams erupt from the surface and they whip through the air. They're dried in the process and they attract to a ground. And so we run this process over a certain period of time and we come up with a nanofiber mat.
It's very much like individual snowflakes coming together. You get a material that's very uniform and has a very high reflectance. It reflects light very well. And then we will take that and cut it into the desired shape for the type of lighting device that we're building.
And we take that mat and we coat it with a specific type of photoluminescent particle. We give it a nice even coating, and then it moves on to a secondary coating stage where we can actually pattern other types of photoluminescent materials on top of that. We've done a lot of work changing patterns, changing amounts, changing types of photoluminescent particles, and that's really my part in the project. So we've experimented with many different types of photoluminescent particles and have come to several that their properties mix together to form a nice white light source.
And then we will take that, incorporate that into our lighting device. Now, our lighting device is powered by a blue light emitting diode. So in our device, we're able to take the blue light from the LED and convert it into full spectrum white light, so blue, green, red. And that's essentially what our material does. And it helps to extract the light from the device very efficiently, so you get the most light out of that device for the amount of electrical power that you're putting in.
The typical maybe incandescent light source would be maybe a 60-watt light. We can use an LED that's a few watts and create the same amount of light coming out of that device. There can be considerable energy savings using these solid-state lighting devices.
If you look at how much electricity and how much energy is consumed just by the lights we use every day, it is roughly 1/4 of all the energy in the United States that is created from electric power plants goes to lighting. So if you improve the efficiency of lighting 10, 20, 30%, it has an enormous impact on the amount of electricity that we consume here in the U.S. and by correspondence also the amount of CO2 emissions and waste from energy power plants are created. So by reducing the energy consumption of lighting devices, can have a significant impact on the energy footprint of the United States.